Hello, you're welcome. This time around, we want to examine differentiation by first principle, and our model example is the function root of x. Remember that differentiation by first principle takes the setup, the limit of f x plus h minus f of x all over h as h approaches 0. The next thing we do is to model the setup to see the function. So modeling the setup to see the function root of x implies that we write the setup in the form root of x plus h minus root of x all on h. Now if you attempt to input 0 for h, you result to an indeterminate form 0 over 0. How does this happen? Observe carefully that we put 0 here. The numerator will result to root of x minus root of x, giving us 0. Now the bottom is h alone, and putting h for 0 will be 0. Right. To avoid the occurrence of an indeterminate form in finding um, or in continuing with our process, what we do is that we multiply both the numerator and the denominator by the conjugate form of the numerator. Now remember, the conjugate form only involves the changing of the sign, assuming it is negative in this case to positive. In the case where it were to be positive, negative would have worked the magic for us. So doing the multiplication, we carefully observe that this term here will multiply this term, which is the same thing. Now, this term also multiply this term. That implies similar thing multiplying a similar thing. But wait, there's also a negative here, which overrules this plus. This draws our attention to the fact that this is a difference of 2 squared. In view of that, we can decide, therefore, to multiply root of x plus h by root of x plus h and write the answer we get. Separate that from what is left with a negative sign or a minus sign and multiply root of x by root of x, and that gives us x. Remember, the denominator has none of such qualities. Therefore, we continue by trying to multiply this part by this part. Now, carefully observe what happens is that the result of the numerator will force us to be able to take away this x, because x minus x will take away any x component in the numerator, whereas the denominator continues to multiply themselves. We will be left with h at the numerator, where we have h outside here multiplying all terms in the denominator. This implies that h has been factored out. Therefore, this h can deal with this h. The result will therefore cause the numerator to be 1, whereas the denominator will be left with the root of x plus h plus root of x. At this point, we can bring our limit back, where we see the limit of this function as h approaches 0 and input our values for h. Now, inputting our values for h will cause us to have root of x plus 0 plus root of x. In view of that, root of x plus root of x, same quantity. Remember, addition of sets, 1 plus 1. The common factor here is root of x. 1 plus 1 giving us 2, whereas the numerator still remains 1. Thus, the derivative of the function f of x, which is equal to root of x, is equal to 1 over 2 root of x. Thank you so much. See you again. Bye for now.